All right, well, we are going to get ready for our final session on this track before the plenary sessions reconvene. And for this, we have a panel discussion. So the panel will be looking on action-oriented innovations from the private sector. So to welcome our panelists to the stage, I am going to hand this over to Dr. Jochen Cremer, who's the assistant professor and co-director at Delft AI Energy Lab at TU Delft. Over to you.
Thank you very much.
Thank you.
Hi, everyone. Yeah, if you want, you can sit already. Okay. While I give the...
Yeah. You first.
All right. Yeah, thank you very much for joining today's panel. While we are setting up the stage, I start introducing already the speakers of today. So first of all, we have Brian Mullins, who is the CEO from Foundry. We have Rutger de Haij, who is head of renewable energy at EscherCloud, who is just on the last side of this, exactly. Then we have Röling, who is blockchain CTO and Global Center of Competence for Energy and Environmental and Utilities at IBM. And then we have Gerdien van der Vreede from EE&U, the Association of Dutch Municipalities. There she is Senior Policy Officer. My name is Jochen Cremer. I'm co-director of the Delft AI Energy Lab and assistant professor at Technical University of Delft. With that, I would like to give you a brief introduction of what this panel is looking into today. So first, the panel is action-oriented innovations from the private sector towards the energy transition. And the vision of today, what we would like to explore together, is how can AI create an impact through innovations for the energy transition. And with that, I also would like to introduce you to one paper which we recently published from the Dutch AI Coalition, which is this paper. I brought it actually with me. Is this one, which is called AI as an Acceleration of the Energy Transition. So from a societal perspective. And there we can find different opportunities and challenges what AI promises for the energy transition. So opportunities, what AI promises is, for instance, to use AI to support regional planning and decision making, but also to make better use of the existing infrastructure and use that more efficiently to really get the most out of the energy system which is there to facilitate renewable energy integration. But then we realized also when writing this paper that there are challenges which Dutch companies face. And those challenges relate from the dynamic process of the energy transition itself. It translates toward this greater uncertainty which then Dutch companies can face, moving to make impact. And that's a little bit the struggle and the corner point which we are also investigating a little bit more today. And with that, maybe I'm handing over to my first speaker today, Gerdien. You were also involved in the process of writing this paper. I know also that you, maybe you can share your view towards this paper and specifically also from EE&U.
Yeah, because I work for EE&U, the Dutch Association of Municipalities, and municipalities are going to play a really large role in decarbonizing the Netherlands. In the climate agreements, we all said that in 2050, all buildings in the Netherlands should be decarbonized, so they shouldn't be using fossil fuel for electricity or for heating. Now, you can imagine that we're basically going to do home improvement on about 9 million buildings in the Netherlands over the course of, say, 30 years. And that's actually quite a lot of work. And municipalities are currently making plans for that. They're making heating visions in which they say for each neighborhood, in what year will decarbonization happen there? When will houses move to a different sort of heating? And obviously, making a plan is not enough, so you'll have to do it in practice. Mm-hmm. So where I think AI comes in is that we're facing a huge challenge, including spatial planning, including involving people, including figuring out what techniques to use for what building and when to do it and how to do it all efficiently. And I think AI can really help there in improving decision making, so it could really support that, hopefully. It might play a role in using the grid more efficiently for demand response. And it might also play a role in decision making. But one of the things that's really important for municipalities and for the government in general to make that happen is that everything we use in AI has to be explainable. It has to be fair, because it's going to impact citizens. It's going to impact the people who live in those houses and who live there with their families. So however we use AI for the energy transition, it's very important that we do it in a very transparent way. And I think this paper really highlights a lot of the things that you need to address for that.
Yeah, that's great. I think there are different grand challenges basically which relate to AI. It's this explainability and the trust which AI needs to come, but also then the technology to the application. And I know that also, Jos, you were involved in writing one specific paper from the World Economic Forum recently, where IBM was targeting or like bring their perspective in. Do you have a use case for us where AI is already where IBM is developing a use case already for the energy transition, but also what was your stake in the World Economic Forum and how do you see the progression? Where are we at the moment?
Yeah, so let me explain just one use case that we have implemented. So chiming on what Gerdien was talking about current buildings, for the city of Copenhagen, we have built a solution that learns the energy behavior of each individual building that is owned by the municipality, being office buildings, workshops, indoor swimming pools. And with that trained model, we can predict how much flexibility is there and to trade it on the balancing service market in Denmark. So, and that's an application that we bring to other countries as well. And rightly so, that explainability, but also robustness of our AI models. And we published a lot of those tools in open source. So if you look at AI Explainability 360 or AI Robustness 360 on the internet, you can find those free tools for you to use and apply it on your own applications that you have. There is also quite a lot of work done in the grid area. For instance, for the Danish high voltage network, they'll calculate every 30 seconds their reliability on the grid with N-1 calculations. And with AI and longitudinal studies, so taking 1 year of data, we find those not the lagging indicators that gives you an indication if you are still in a good state of your grid, but also the leading indicators. What is going to change that state of robustness of the grid in the future? So those applications are now available, and I'm very interested and enthusiastic to see how those develop going forward. Yeah?
Absolutely, I think that's an exciting take forward on that. I mean, you mentioned also the technology on the one hand side is available, but then on the other side, there are open source tools, as you said, right, where you can apply it to some different applications and so on, and like develop this on your own. But are we then ready, would you say, towards that every engineer can basically use those tools and implement it into their applications?
So our ambition is that from our ethics center, which is driven by IBM Research, is to provide those tools for everyone to use, so that they can test and validate their own models that they create with their own tools of preference, and test it for robustness and for fairness and for fair use based on those tool sets. So we have a common understanding of that the AI applications are doing what we designed and desire that they do. Yeah.
That's great. I think that sounds quite well thought and strategic about how we can use AI to make impact on the energy transition. Maybe we can hand over. What is your view, Brian, towards making impact through AI? Like, do you have another use case for us? How do you see, this playing out? Also, what previously Jos said.
Yeah, absolutely. At Foundry, we focus on high-stakes applications of AI. That's where a decision affects someone's life or is made at the scale of a population. When that happens, you have to go beyond kind of the first level of explainability and understand the fundamental method of action and what the failure modes might be. And in particular, one of the use cases we did was working with the UK government and at the local council level on electric vehicle charge point placement optimization. So these are decisions that the local governments are going to make about how do they invest in infrastructure that can incentivize the adoption of zero-emission vehicles, supporting objectives at the national level for transition to net zero. And it's a complex challenge because you have to take into consideration things like the electrical infrastructure as well as the road networks. But you also have to overlay what you know about the people, the exogenous data that represents the socioeconomic conditions in the communities. How likely are they to have charging or even off-street parking available at their home? What would their place of business look like, and could they charge there? And most importantly, after taking those into consideration and deciding where to put these charge points, you need to understand why those recommendations were made so you can stand behind them. Because the citizens whose lives that are affected might have a different economic development outcome over a generation or more. And that's why it's important that these things and these use cases are really considered for how high the stakes are.
Okay. Yeah, you touched upon several very relevant points, I guess, right? I mean, on the one side is the kind of infrastructure which need to be there and the policy or the regulations, but then also this integration of the different energy, right? And it's not only electricity, but it's also other energy sources which come together. And that's also adding then the kind of constraints a little bit, right? But maybe I'm now handing over to Rutger to tell us a bit more how these challenges also play a role for you. Like when in your daily operation, when you develop AI, maybe you can elaborate a bit more how these challenges play out for you.
Yeah, so we as EscherCloud, we're a provider of high-performance compute and focusing on AI as well. I think energy is a big thing also in compute. The compute industry is using more and more energy, and we need to make sure that we're doing this in the most energy efficient way possible. AI can definitely be a way, on the one hand, to optimize the energy systems, and technology is there. I think with regulation, we still need to make a step to really make sure that we can unlock the full potential of AI. But we also need to make sure, AI needs a lot of compute power, that we do this in the most efficient way possible. And that we look at the energy system as a whole. Now, AI in Europe, I think, is going through a development. We still have some steps to make before we're at the level of China and the US. But what we're also trying to do, and we do that in partnership with NVIDIA, is to incentivize and stimulate AI startups to develop their offering. So tomorrow we will also be opening our AI lab, which is powered by EscherCloud and NVIDIA. And we give a place to work to the startups, where they can also show their technologies, but at the same time we provide them with access to compute, because it's also something that is lacking and sometimes very difficult to get, to really get compute power. And at the same time, the startups also get access to NVIDIA's Inception program. So we'll be hosting 8 companies from different sectors in the beginning, and over time we hope to grow that significantly.
Okay, so basically then the data center will provide also there for new startups basically to use those facilities, right, and to develop new tools. Yeah. Maybe then using from IBM the open source software as well to develop and to put this really into practice. That's great. So there's a lot of potential on the one hand side, but let's now focus maybe in the next few minutes more on the constraints. Right, so I mean, you have already touched upon a few points, like regulatory is not there yet. We need to develop more the governments surrounding using data. So also the explainability and so on is also a challenge. So I was wondering, which kind of constraints do you think are really there to make no impact with AI? Right, so maybe we can. If anyone wants to share their initial thought about this.
Yes, yeah? I can do that. Yes. So to chime in, so IBM developed a new chipset, a Tellurium chipset, specially designed for AI algorithms. Yeah, so and that will improve the performance of AI by a factor of 100. Yeah, so they will become later available and for you to put in your data center. So that's one. In the World Economic Forum paper, 3 categories of challenges are being addressed, like so governance, design, and enablement. So let me pick 2 from enablement of challenges that we face. So one is the expertise. So if AI sticks within the nerdy environment of scientists, then it will not receive the broad exceptions and adaptations that we need to face the challenges of the energy transition. Yeah, so the transition itself will take 25, 30 years. So we need to have good instruments to steer the transition into the direction and the output that we want and to gain. So and the other aspect, as we discussed a little bit in our preparation, is data. Yeah, so data in the energy environment is quite a complicated aspect, because some data elements are eligible for GDPR, so not freely available, at least not to the parties who are looking for it right now. Some data is then hidden behind the GDPR regulation, and perhaps we need to have a more sophisticated discussion on which elements of the data, in which periods are being exposed for utilizing in getting understanding, and also finding not only the lag indicators but also the leading indicators of how changes are expected, so that we don't have surprises like in the newspaper that some area is overloaded and cannot accommodate new renewable energy generation. Yeah, so to align also the policy making, the planning for build-outs of those new renewable energy.
You had some thoughts? Or?
Yes, I can really relate to what you were saying about enablement, because I'm going to be honest with you, I was a bit nervous about coming here today, and that really has everything to do with framing. Because the good news is that I'm quite sure I know more about AI, machine learning, and basically anything data-related than at least 90% of the people working for the government. So from that point of view, I would say I'm safe. It's very confidence-inspiring. But from another point of view, I was also quite sure that I know less about machine learning, AI, and anything data-related than about 90% of the people attending this conference. That's not so confidence-inspiring. But it was also telling me something. Because if I'm the nerd in the government, but not the nerd over here, if you want to make use of AI for societal challenges, government and the private sector and academia, they need a better understanding of each other's worlds, of what works in government, of what works in academia, and what works in the private sector, and what the boundary conditions are for each of those ways of working. And for government, fair AI is very important, as I already mentioned, explainable AI, because you're touching upon the lives of people, and you want to do that you want to be very careful in doing that. And then in the private sector, in academia, you'll have other boundary conditions. And I think that in order to really make good use of AI in the energy transition, to use its full potential, government, the private sector, and academia need a much better understanding of each other's realities than there is right now.
Yeah. I think, I mean, it's basically then about exploring these kind of boundaries, right, and testing them, stressing them, and pushing there towards, and to create this kind of common understanding of really what's needed. So I was wondering, maybe, Brian, what's your relation to, if you talk to a regulator on that, right, and where you really want to implement some new AI tool, like what is there the boundary condition you would face, or like what is the kind of conversation? Do you face a similar experience as Gerdien was just describing?
Yeah, I think there's 2 angles when you answer that question you have to think about. The first is the impact of the AI itself, which, if used irresponsibly, can use a lot of power and create a lot of carbon and be a problem in and of itself. So you have to start from a position of responsibility. But then you have to think about what you're using from a method standpoint. how compatible it is with the data that, and what does that data represent? And then what's the direction of the intervention? Like how does it, as a system, solve a problem or not solve a problem? You know, these stakes are really high. I think if you want to learn how to play a game, you can lose 2 billion games, right? If you want to launch a rocket to the moon or solve the problem of climate, you got to get it right the first time.
Yeah, that's great. So basically then there's this kind of technology, the system-specific boundary conditions from the technology itself, and then there's this regulatory and communication part to it, right? Yeah. Right.
Yeah, and I think it's also, you know, the unknown. So what is AI exactly? And of course, the social acceptance. So, you know, explain people in a simple way what AI does for you and what is actually happening behind the scenes without, you know, that people's data is protected. I think that's something that's very important.
Okay. Is that now related to what we heard earlier? Because we heard earlier that explainable AI, this kind of term, right? Is that now, would you say, a similar thinking which you have, that AI, because first of all, I mean, an engineer or anyone like who works with AI wants to understand what the technique itself can do, right? But then explainable AI is something different, where I assume the AI communicates itself how to get from input to output, how to make the decision, right? So how are these two terms related to it? I mean, can we also then design AI technology which is inherently more explainable and through that maybe reach more global public understanding of it, or?
We have to.
We have to.
We have to. Explainability today is for data scientists and researchers. Explainability has to move to users of systems, but that's not enough either, right? It has to explain itself to the people whose lives are affected by the decisions.
Because really then this communication aspect, right? So it's only more communication on the one hand side between our different organizations to make this work, because we speak different languages, but then also really to the general public, right? And to really say AI is maybe not this kind of threatening technique, but it also has some opportunities to offer. So it's maybe, it's this communication aspect.
And it's on us. If the people can't understand, that's our fault. We need to bridge the gap.
Yeah. Great. Okay, so
So from an IBM standpoint, we have rebranded ourselves as a hybrid cloud AI company, and currently we are training 200,000 people on AI fundamentals. So that's mandatory training for all of my colleagues and myself as well. To get a foundational understanding of what is AI, what are the different aspects, what are the different elements, what is the impact on data, what's the ethics, without understanding how the models need to be programmed and how the technology works, but more on a business and a human level, understand what comprises AI. And I think that's in need of, I think, many other organizations as well. So to unleash this from the engineering backrooms, where they do that fancy stuff, building the models.
I mean,
I totally agree, because in the government we have tons of trainees every year, and we send them to project management courses, because we know if we don't, they'll blotch up and everybody will be the worse for it. We send them to interpersonal skills training, because we need them to be able to work on multidisciplinary teams. We need them to be able to work with other people. We need them to be able to communicate with other people. And we know that if you don't teach them that while they're trainees, it'll get pretty hard later on. What we don't do is send them to a data science course. What we don't do is send them through basic AI learning. And I think that really is something that we should do. We've got all these young, bright trainees from all sorts of backgrounds, but we fail to teach them about the impact of data. We fail to teach them about the impact of AI. And I really think that if we would start doing that this year, preferably, it would add up in the long term. Because right now, the trainees, within 20 years, they'll be decision makers. So if we teach them now, we'll benefit in the long term.
Absolutely. Yeah, I think that's also, I mean, from our academic viewpoint, our vision here at TU Delft is to really in the future that every graduate student has some knowledge of data science. So this really spans from business students towards management and policy and engineers and so on. So that's also, in our view, very important here in the Netherlands to boost the education system towards that every graduate from university has this knowledge. But then it's really also about the professional skill training. And there we have the workforce. Thinking about the energy transition, we cannot wait so long for the 20 years until those graduates then are decision makers. So we don't have this time. So it's really also a call to action and I agree as well to support the employees and to really build up the skill towards more data and also understanding the topic of AI.
But Jochen, we shouldn't underestimate the energy transition. That's not a process of 1 year. That will take us a few decades to get that done.
Yeah.
I'd love to send our senior management to a data science course as well, but they're a bit harder to steer than our trainees.
Yeah, it's also again then the different ways of communication.
Yeah.
Right? Also, there are different types of courses probably are needed and different types of engagement with those employees. Great. All right. With that, I think we are moving to the question and answer part. If you have any questions, we have moving microphones. I'm also observing you can answer. You can maybe engage also online. My battery just died from the iPad, so maybe ask questions in person. So if there are any questions, please feel free to ask our panelists. Otherwise, we have a lot of topics to talk about, but there's, I think, one question. Please, can you say your name, affiliation, and who you would like to address in the question?
Peter Schoustra with Aegon. A question, I'm not sure who I would aim it at directly. Towards the last topic, we're talking about how AI and the lack of understanding of AI is hard for decision makers. But is there, in your point of view, and I think it's mainly for Jos and Gerdien, since they were talking about this, distinction between AI and other upcoming technologies? I know it's a buzzword, but let's consider blockchain, for example. Is there a distinct difference between AI and such, or do you consider this lack of understanding to be impactful for all of these?
Yeah, so if I can start, right, so AI is a container phrase that has a lot of different elements in the box. Yeah, and one of the aspects that you are referring to is for combination with other technologies that are emerging, like blockchain. On a business level, we say, well, we build multi-party intelligent workflows. And what does it mean? Does it mean that we see that companies need to collaborate together? And due to COVID, more and more is done virtually. So we need to align all those processes between those different entities. But plain data shoveling is not enough. So the data shoveling can be done using blockchain, so you get visibility in your whole value chain. And each party needs to implement some analytics on top of it, some machine learning, some AI models, to make it intelligent, to support your employees for decision making. And explainability then says, well, these are the alternatives and this is the confidence levels of each of the answers out of the algorithm to suggest to the employee what action to take. And it's then up to the employee to say, well, I derive from the top decision because I don't have a good gut feeling, I take the second one. Yeah, so those methods are already being used in medicine, in operating theaters, and more also in insurance environment for yourself as well.
I'm afraid within municipalities that's still a bit of a future scenario. We're not doing it right now. We're currently still very happy if we got the basic data and everybody's got access to that and can use it for decision making, and they actually do use it for decision making. But I think in the future, we're definitely heading in that direction.
Yeah, so another application more on the energy front that we are discussing today is a situation that is in North America where you have overhead lines. For that, there is a weather prediction module that suggests where to put your trucks with spare equipment and your engineers in order to most quickly be able to repair after a storm damage, which is so frequently happening in North America. Yeah, so not so much in Europe so far. So.
All right. Yeah, thanks. Does anyone else have any more questions? Please raise your hand. Yeah.
Hi. So I really am glad that you made the point about how important the explainability of AI is, especially when it comes to getting buy-in from all levels. So wondering if you could speak a bit more about where we're at today in being able to hold AI accountable for explanation, and also does this put undue pressure on the people in charge of those data sets and AI?
Is that a question specifically to one of the speakers, or?
No, to everyone.
Yeah, okay.
Yep.
Anyone wants to?
I think when I made the comment about the levels, I think it relates directly to the question about what's the state of explainability today, and I think it's just scratching the surface, right? Explainability is a very thin veneer that is much more valuable to someone who's at the research level or is a data scientist, and to get more value and to understand more about fundamental operation is often overlooked or ignored. And a lot of the explainability and responsibility discussion is at the philosophic level today, which has a lot of value. But we have to have technology that underpins that, where you have systemic trust and systemic responsibility that can be quantified and proved mathematically.
Great. All right.
So, I also expect that some industries are front runners in addressing those issues. So currently it's on the table for autonomous vehicles. Yeah, autonomous vehicles have a lot of AI and machine learning internally and running in the vehicle. So, legislation and law and regulation is now emerging, right, based on the learnings that we do as a society. So, and I don't think there is a one answer for all the questions on this front, but we learn and develop it as we go. Yeah.
I think that's maybe also now a little bit the closing of this session today. As you said, there are a lot of different questions and answers, and I'm sure the speakers will be around if you have many other questions to address them directly. With that, maybe I just quickly conclude our panel a little bit, because it was quite an interesting and stimulating discussion for myself. My viewpoint is that we have all realized that AI plays a major role in the energy transition, and it is basically this kind of communication aspect between the different players involved in the energy transition. It's about communicating, skill development of employees as well as students as well, but it's also then the system boundary conditions which are still existing. Thinking about explainable AI and so on, so are still open questions. I guess lots of things to work on, but also we can be hopeful that AI really keeps up with this promise. With that, thank you very much to all of my speakers. It was really a pleasure, and also to you all to join us today.
Thank you so much, Jochen.